This problem walkthrough video will demonstrate how to use the GAMMA.INV, RAND, COUNT, and COUNTIF functions along with what-if analysis in Microsoft Excel to execute simulation trials to evaluate a new product launch. Here's the data for our problem. The management of Madeira Computing is considering the introduction of a wearable electronic device with the functionality of a laptop, computer, and phone. The fixed cost to launch the new product is $300,000. The variable cost for the product is expected to be between $128 and $192, with a most likely value of $160 per unit. The product will sell for $240 per unit. Demand for the product is expected to range from 0 to approximately 20,000 units, with 4,000 units the most likely. The data has been collected in a Microsoft Excel file. Download the spreadsheet and complete the following requirements. For requirement A, we're asked to develop a what-if spreadsheet computer profit model for this product in the base case, worst case, and best case scenarios. Requirement B directs us to model the variable cost as a uniform random variable with a minimum of $128 and a maximum of $192. Model the product demand as 1,000 times the value of a gamma random variable with an alpha parameter of 3 and a beta of 2. And construct a simulation model to estimate the average profit and the probability that the project will result in a loss. Requirement C asks for a recommendation regarding whether to launch the product. Let's open up our downloaded Excel data file and complete the requirements. Here are the parameters for our problem as provided in the data. We have the selling price and fixed costs in cells B5 and B6. Cells B8 through B10 include the minimum, maximum, and most likely variable costs, and cells B12 through B14 include the maximum, minimum, and most likely estimated demand for the product. Let's start by creating a work area for our model. I'll enter labels for the best case, worst case, and base case profit results in cells A18 through A20, uniform variable cost per unit in cell A22, demand based on the gamma distribution in cell A23, profit in cell A25, and mean profit and probability of a loss in cells A27 and A28. Next, I'll select our answer cells B18 through B20 and shade them green. I'll shade cells B22, 23, and 25 blue, and cells B27 and B28 green as well. Now we can work on requirement A to determine the profits under the best case, worst case, and base case scenarios. The best case profit scenario is calculated as the difference between the selling price and the minimum variable cost times the best case demand, then subtracting the fixed costs. So click on cell B18 and type the equal sign, followed by 2 opening parentheses for a nested formula here. Select the unit selling price of $240 in cell B5 and press F4 to lock the cell reference. Type a minus sign and select the minimum variable cost of $128 in cell B8, followed by a closing parenthesis, and then a multiplication sign. Then select the maximum demand of 20,000 units in cell B12, followed by a closing parenthesis, then a minus sign, and select the fixed costs of $300,000 in cell B6, and press F4 to lock in the cell reference. And press Enter or Return, and we should end up with a best case profit of $1,940,000. Next, for the worst case profit, which would be the selling price less the maximum variable cost, multiplied by the worst case demand, then subtract the fixed costs. The base case is the difference between the sales price and the most likely variable cost, multiplied by the most likely demand, then subtracting the fixed cost. Since we locked in the cell references to the selling price and the fixed costs, we can just copy and paste our best case formula down to the other 2 cells by clicking on cell B18 and double-clicking or clicking and dragging the little green square down to cell B20, where we should end up with a loss of $300,000 for the worst case scenario and $20,000 for the base case. The worst case scenario shows a loss equal to the fixed cost in this example because the worst case demand is 0, and therefore there will be no sales or any variable costs. Now on to requirement B, where we want to create a model of variable cost as a uniform random variable between $128 and $192, and model demand as 1,000 times the value of a gamma random variable with alpha and beta parameters of 3 and 2 respectively. For the uniform variable cost, click on cell B22 and type the equal sign. Select the minimum variable cost in cell B8, followed by the plus sign and an opening parenthesis. Then click on the maximum variable cost in cell B9, then type a minus sign, and select the minimum variable cost again in cell B8, followed by a closing parenthesis. Then type the multiplication sign and type RAND, R-A-N-D, to bring up that function. The RAND function returns a random number between 0 and 1, evenly distributed. When you see the function in the list, select it or press the Tab key. An opening parenthesis is automatically applied, and you just want to type a closing parenthesis to complete the function. Press Return or Enter, and you'll get a result. My answer here is $169.75, but yours will be different, and it will change with every new calculation in the worksheet. For the demand, click on cell B23 and type the equal sign and enter 1000, and type the multiplication sign, then start typing GAMMA.INV, G-A-M-M-A.INV, to bring up the function. The GAMMA.INV function returns the inverse of the gamma cumulative distribution given specific parameters for alpha and beta. Select the function or press the Tab key. You'll see the first parameter is a probability, which we want to be random, so type RAND followed by a set of parentheses to generate the random variable. Then type a comma followed by the number 3 for the alpha parameter, then a comma followed by the number 2 for the beta parameter. Type a closing parenthesis and press Enter or Return to generate the result. My demand result is 7,148, and yours will be different due to the randomization. Also notice that the variable cost changed as well, since it's also randomized. Now we can calculate the profit based on randomized demand and variable costs. So click on cell B25, type the equal sign followed by 2 opening parentheses. Select the selling price in cell B5, then type the minus sign and select the uniform variable cost we calculated in cell B22, followed by a closing parenthesis. Then type the multiplication sign and select the randomized demand in cell B23. Type a minus sign and select the fixed costs on cell B6, and press Enter or Return, and Excel will calculate a new profit based on newly generated variable costs and demand. Now we'll use the randomized profit to determine the mean or average expected profit and probability of a loss over 1,000 randomized trials. First, let's create a new worksheet by pressing the plus sign at the bottom next to the Model tab, and let's name it Trials. I'll zoom in to 200%. In cells A1 and B1, I'll enter the column headings Trial and Profit and make them boldface. Next, I'll enter a 1 and a 2 in cells A2 and A3. Then select them and drag the little green square all the way down to row 1001 to generate the numbers up to 1,000. Next, for the profit, click back on cell B2 and type the equal sign. Then click the Model Worksheet tab to take us back to the Model Worksheet and select the profit we just calculated in cell B25 and press Enter, and the current result for profit from the Model Worksheet is transferred here. Next, select all the cells from A2 through to B1001. Be sure to not include the header row 1. Next, click the Data menu from the menu bar, and then in the Forecast group on the ribbon, click the What If Analysis button, then select Data Table. The Data Table dialog will pop up, and for the row input cell, leave that blank. Click on the Column Input cell box, and click on cell A1, then click OK, and boom, now you have 1,000 trials from the randomized variable cost and demand. Let's format those as currency, so select all of column B, and then select the Home menu from the menu bar. Then in the Numbers group on the ribbon, click the pull-down arrow and select currency from the list, and remove the decimal places by clicking the Decrease Decimal button in the Number group. Now all the heavy lifting's done, and we can go back to our model worksheet and calculate the mean profit and probability of loss based on the trials. For the mean profit, click on cell B27, type the equal sign. Then start typing average to bring up the function. Select it or press the Tab key. Now we want to click on the trial sheet and select all of the profit trials in cells B2 through B1001 and press Enter or Return. My mean profit is $173,777.53. Let's format that as currency with no decimal places by clicking on the drop-down arrow in the Number group in the Home menu ribbon and selecting currency from the list, then press the decrease decimal button twice to remove the decimals. Now for the probability of a loss, which is simply the number of losses in the trials divided by the total number of trials. Click on cell B28 and type the equal sign, and type COUNTIF to bring up the function. Select it or press the Tab key, and then click on the Trials tab to go to the worksheet and click on cell B2. Now you can either scroll all the way down to cell B1001 or just type a colon, then B1001. Then type a comma, then an opening quotation mark, followed by the less than sign, and type a 0, followed by a closing quotation mark, then a closing parenthesis. Now type the divide sign and type the word count to bring up the function. Select it or press the Tab key, click on cell B2, followed by a colon, then B1001, followed by a closing parenthesis. This will count the number of losses in the cell range B2 through B1001 and divide by the total number of trials. Press Enter or Return, and we're taken back to the model worksheet, and I have a resulting probability of 0.311. Let's format that as a percentage by clicking the percent sign in the number group in the ribbon, and then adding one decimal place with the increased decimal button. The probability of a loss is around 31.1%. If we keep pressing F9, we can see that the randomization causes a loss probability to increase and decrease, but stays somewhat within the range of 28 to 33%. My final mean profit is 176,786, with a loss probability of 33.9%. And now we have everything we need to state our answers to the requirements. For requirement A, the best case profit is $1,940,000. The worst case is a loss of $300,000, and the base case profit is $20,000. For requirement B from our trials, the average profit is 176,786, and the probability of a loss is 33.9%. Your numbers will be slightly different, but not far off from the 30% range with 1,000 trials. As for a recommendation in requirement C, we can see that the average profit is fairly high, and the probability of a risk is greater than 15%. Thus, Madeira Computing may not want to launch the product if they have a low risk tolerance. And that's it. We've answered all the requirements.